Thank you. So today I'm going to talk about the optimal auction versus anonymous pricing beyond linear utility. This is a joint work with Yiding, Feng, and my advisor, Jason Hartline. The problem we are going to talk about is the seller have a single item sell to a set of N agents. And the objective here we care about is to maximize the revenue of the seller. Most of work in the literature has focused on agents with linear utility, which means that the utility U of this agent is equivalent to her valuation V times the allocation X minus her payment T. But when the agents have budget constraints, the utility of the agent is only linear if the payment of the agent does not exceed her budget constraint. This is a kind of nonlinearity, and the focus of our work is to talk about the revenue maximization for agents with nonlinear utilities. There has been a serious work in the literature focusing on the comparison between the simple maximum and the optimal auction. Most of them have focused on agents with linear utility. We know that when there is only a single agent, posting a single price is actually optimal. And when there are multiple agents, the optimal mechanism becomes more complicated, which actually involves letting agents competing with each other. But with the assumption of the regularity, we know that the simple mechanism based on pricing is actually approximately optimal. For agents with nonlinear utilities, things becomes more complicated. Even there is only a single agent, we know that posting a price to this single agent is suboptimal. And when there are multiple agents, the literature knows only little about the characterization of the optimal auction. And the main contribution of our work is to say that for agents with nonlinear utility, there exists very simple mechanism, which is just posting price to different agents that is approximately optimal. We show this by first propose a definition of approximate regularity. Roughly speaking, this is just to say that pricing is good for the single agent problem. And using this definition of approximate regularity, we are able to reduce the analysis of posting price to agents from agents with nonlinear utilities to agents with linear utilities. And by showing that this approximate regularity is actually satisfied for a broad class of agents with nonlinear utility, we show that simple mechanism based on pricing is actually approximately optimal for multiple agents with nonlinear utilities. Note that our work applies for a broad class of agents with nonlinear utilities. For simplicity of this talk, we will only focus on a canonical model, which we call the independent private budgets. Here, the seller sells a single item to a set of N agents, and we use V to denote the valuation profile and B to denote the budgets. The valuation distribution F and the budget distribution F are both product distributions, and F is independent with the budget distribution G. We use X to denote the allocation and T to denote the payment. The constraint we have on the allocation is that this item can never sold to two agents at the same time. And the utility of the agent is only linear if the payment of this agent does not exceed her budget constraint. In this model, we will drop the subscript if there is only a single agent. And an example theorem come from this canonical model is that if for every agent, the valuation distribution for each agent is regular, and the budget distribution satisfies the monotone hazard rate, then we prove that the anonymous pricing is a 3E approximation to the optimal revenue. Before getting into detail, here's an outline of what I'm going to talk about next. First, I will going to give a formal definition of the ex-ante relaxation and why we care about this relaxation, and also a formal definition of anonymous pricing, which is the simple maximum we care about. And I will also tell you the definition of approximate regularity for agents with nonlinear utilities and show you how to use this regularity to reduce the analysis of anonymous pricing for agents with nonlinear utility to agents with linear utility. And for our example theorem, we show that if agents have regular valuation distribution and budget distribution satisfy monotopic rate, then the approximate regularity is satisfied, which directly implies that anonymous pricing is a 3E approximation. So as promised, first I will talk about the ex-ante relaxation. In general, if we want to get tight ratio between anonymous price and optimal revenue, we want to directly compare it with the optimal revenue, which requires solving complex optimization under the interim feasibility constraints of the agents. However, in general, for agents with nonlinear utility, this is a hard problem and we do not have a closed form characterization for it. So we take a step back and consider the ex-ante relaxation, which only requires that in expectation, this item can sold to at most one agent. The benefit of this relaxation is that it reduces the optimization problem to each single agent. And since there's a relaxation, it can be served as a natural upper bound for the optimal revenue. To formally define the optimal ex-ante revenue, first we define the ex-ante revenue curve, which is a mapping from the ex-ante probability Q to the optimal revenue for this single agent problem, which sells of probability exactly equal to Q. The figure on the right corner is an illustration of the ex-ante revenue curve. And the optimal ex-ante revenue is just to maximize the sum of the ex-ante revenue for every agent subject to the constraint. The probability sold to every agent is at most 1. Note that the ex-ante revenue is well defined given the ex-ante revenue curves, meaning that if we have two sets of agents, one set of agents has nonlinear utility and another set of agents has linear utility, if their ex-ante revenue curve happens to be the same, then their optimal ex-ante relaxation revenue will be exactly the same, regardless of their utility functions. Next, we are going to define the anonymous pricing similarly, given the price posting revenue curve, which is a mapping from the probability Q to the optimal revenue for the single agent problem that sells with exactly this probability. Note that here we define the price to be the per unit price, meaning that if for a budget agent with valuation V and budget B, for any price lower than her valuation, she will actually purchase at a location which is the minimum between 1 and budget B over the price. Then the anonymous pricing mechanism for the seller is just to post an anonymous per unit price to every single agent. Each agent can arrive in any arbitrary order and purchase her favorite lottery given this anonymous per unit price if this item is not sold to any of the previous agents. Then the anonymous pricing revenue is just the multiplication of this price and 1 minus the probability that this item is not sold to any of the agents. Here the function Q is just a mapping from the price to the probability this item is sold given the price posting revenue curve. Note that the anonymous pricing revenue is also well defined given the price posting revenue curves. Now we have defined what is anonymous pricing and what is the ex-ante realization. Next, I'm going to review the known result for agents with linear utilities. We know that for concave revenue curves, anonymous pricing is an E approximation to the ex-ante relaxation on the same revenue curve. And for agents with linear utilities, we say that the valuation distribution for this agent is regular if her price posting revenue curve is exactly equivalent to her ex-ante revenue curve. Note that a simple fact is the ex-ante revenue curve for every agent are always concave. So a simple corollary to this fact is for agents with regular valuation distributions, anonymous pricing is an E approximation to the ex-ante relaxation. What we want to show is to generalize this result to agents with nonlinear utilities. Note that here an important assumption is the regularity assumption, which requires the price post-new revenue curve as the equivalent to the ex-ante revenue curve. But in general, for agents with nonlinear utilities, those two revenue curves are not equivalent. So we want to have an approximate version of that. We define the price post-new revenue curve to be close to the ex-ante revenue curve as follows. For this figure, the red curve is the ex-ante revenue curve and the black line is the price post-new revenue curve. If we shrink the ex-ante revenue curve by a zeta factor, and we consider the monotone extension of the price post-new revenue curve, if the gray dashed line is always above the red dashed line, then we say the price post-new revenue curve is zeta close to the ex-ante revenue curve. And we define an agent to be zeta regular if the price post-new revenue curve is concave and is also zeta close to the ex-ante revenue curve. With this definition of approximate regularity, we have this approximation result, which is for agents with for zeta regular agents, unknown pricing as a E times zeta approximation to the ex-ante relaxation. The proof goes with two steps. First, if for every agent, the price post-new revenue curve is zeta close to the ex-ante revenue curve, then the ex-ante relaxation revenue on the price post-new revenue curve is a zeta approximation to the ex-ante relaxation on the ex-ante revenue curves. And this step is actually very straightforward. And using the result for agents with linear utilities, we show that if every agent, the price post-new revenue curve is concave, then unknown pricing is an E approximation to the ex-ante revenue on the price post-new revenue curve. Combining those two inequalities gives us the desired theorem. Now we have shown that if agents satisfies the approximate regularity, then we have approximate optimality for unknown pricing. Next, we are going to show that this definition of regularity is actually satisfied for agents with nonlinear utilities. For example, if the valuation distribution is regular and the budget information for this agent is public information, by extending the known result, we can show that this agent is actually one regular, which implies that in terms of comparison between announced pricing and ex-ante relaxation, the worst case happens actually when the budget never binds. And a more central result for this talk is to say that for private budget agents, if the valuation distribution is regular and the private budget distribution satisfies the monotone hazard rate, then this agent is actually 3 regular. Before giving the intuition of how to prove this, we should note that this is a worst case analysis. Consider the canonical example where the valuation distribution and the budget distribution are both uniform distributions. This has been studied a lot in the literature, and the optimal mechanism for this simple example is actually very complex. And we can actually show that this is an easy case for us because the price post-new revenue curve and the ex-ante revenue curve for this example is actually close, so the performance of anomalous pricing is actually good. Back to this lemma. First, with these two assumptions, we can directly algebraically calculate that the price post-new revenue curve is concave. And with only the assumption that the valuation distribution is regular, we can show that the price post-new revenue curve is 3 close to the ex-ante revenue curve. There are several main ingredients in proving this lemma, and we generalize the technique from those results to apply in our setting to prove this closeness result. Due to the time constraint, I will not exactly show you how we generalize their result, but instead I will directly tell you a more simplified result, which have intuition to tell you why these revenue curves are close to each other. The simplified result is to say that for the single agent problem, when this agent have regular valuation distribution, then posting a single price is actually a true approximation to the optimal revenue. We compare this for each realized budget, and we know that if this budget is known to the seller, then with regular valuation distribution, the optimal mechanism is to post price between the minimum of the price M, which is the price that maximizes revenue, as if this agent does not have budget constraint, and between this price and the budget of this agent. So as illustrated in this figure, the black solid line is the price post-new revenue curve for this agent as if it doesn't have budget constraint. And in this figure, this agent has smaller budget, so the optimal mechanism is to post the budget, achieves revenue which is the height of the intersection. Since the width is 1, so the revenue is the area of the gray rectangle. And the random sample mechanism is to just first draw a sample from the valuation distribution and post this price as the per unit price to this single agent. The revenue the seller is going to achieve is exactly equivalent to the blue area. And since the valuation distribution is regular, this price post-new revenue curve is concave. The blue area is larger than the white dot triangle area, which is a true approximation to the gray rectangle. So this price posting mechanism is a true approximation to the optimal revenue. So to conclude this talk, we know that for agents with nonlinear utilities, optimal mechanism is very complex, but there exists simple mechanism which just based on posting price every agent that is approximately optimal. We show this by proposing an approximate regularity definition for agents with nonlinear utilities. And using this regularity, we are able to reduce the analysis of anonymous pricing from agents with nonlinear utility to agents with linear utility. And we finally show that this proposed definition of approximate regularity is actually satisfied for a broad class of agents with nonlinear utilities. And note that this regularity is not only can be used to show that anonymous pricing is good, we can also show that sequential post price is also approximately optimal. And that's it. Thank you.
Do you know, is it possible to relax the MHR assumption for like regular for a budget?
You mean for anonymous pricing?
Yeah, for like the settings percent.
So actually in our paper, we have a slightly weaker assumption than the MHR assumption, which is basic to say that the probability budget expectation must be a constant. And we also show that with the weaker assumption, we cannot achieve constant approximation for anonymous pricing.
So regular, that's fine.
No.